welcome to the radical chain polymerization chapter. In this particular chapter, we are going to discuss about the radical chain polymerization, and we will discuss about the basic concepts of resonance, because resonance is an integral part of polymer reaction engineering. Then we will have a comparison between the radical and step growth polymerization. So let us start with the radical chain polymerization. Now, a reactive species, because as we know that in all kind of polymeric system there is a reactive species, and this reactive species initiate the polymerization reaction. So a reactive species, say let us say in this case a star is generated from some compound, say I, which is usually called initiator, and it initiates the chain polymerization like this. Now, if you recall that in the priori we discussed about the three stage of polymerization: initiation, propagation and termination. Now, if you recall that not every monomer or not every molecule do participate in the polymerization reaction. The formation or the presence of either functional group, double bond or any kind of a reactive species is must for having the polymerization reaction take place. Now, these reactive species, whatever is we are discussing, may be a free radical, may be cation or may be anion. So, depending upon the reaction involved, now these reactive species are either attached to a monomer molecule, say by opening any pi bond to form a new radical cation or anion center. Now, this reaction is usually, whatever reaction we are going to discuss is usually repeated as many monomer molecules are added successively or sequentially to circulate the reactive center continuously. Now, let us have an example of this particular approach. We are having this particular molecule. Here this is this X is any functional group or any kind of hydrocarbon chain. Now, it is related with this radical, so it may form now this is transferred to here. Now, if we keep on further increasing the chain, then this H2C, CHX, this one may have like this. Now, these are the repeating units. Now, if we keep on moving the things in the same direction, then we may have again that is so this is you can say the stages of various polymerization. Another we may take another example of this particular approach for cyclic and aromatic compound and aromatic compounds, like we may have now you see that here we are performing the ring opening approach. further if we go ahead with the then phenyl ring. pH stands for phenyl ring. Now you see here these two are the repeating units. Now if further we carry out up to the nth molecule level, then this may become now this is my polymer. So this is again you see that this is the basic genesis of radical chain polymerization. Now at some stage polymer growth is terminated by the degradation, and if you recall that we discussed about initiation, propagation and termination, and sometimes it may be terminated, the chain growth may be terminated by the degradation of any kind of reactive center by an effective reaction. Sometimes it depends on the form of reactive center and precise condition of any reaction. Now let us have a look about this this thing. If we take the previous example, now the chain can be terminated through another reactive centers, like here we are having this polymer with us, CH2CHX. Now this is another reactive center. Now here this chain is auto terminated with the help of this reactive center. So both of them may combine together to truncate the reaction, and that's why you may be at the stage of completion of this polymerization reaction. Now this is the way through which you can truncate this further polymerization. So this is my entire polymer. So the termination in say ionic chain polymerization, it can be proceed either through recombination of counter ions like this we discussed in the previous example, or by forming an sterically hindered ion having very broad chain distribution. Now to understand this particular effect of substituent active species and sometimes the charge distribution over the active monomer species, the understanding of a molecular orbital theory or resonance is required. That is why the second point in this approach was the discussion about the resonance. Now here the basic concept of resonance they tried to be recalled before understanding that there are certain FAQs or frequently asked questions which are related to this resonance concept, that what is the resonance. We discussed about the pi system. Now this resonance is usually a delocalization of electrons within molecules, sometimes this type of approach. Now another thing is that what is its effect? People may ask that what are their effects. Now the basic effect of these resonating concept is to increase the stability of the molecule with respect to the polymeric system. Sometimes we may ask that what are the conjugates or what is conjugate. So there are two subjects in usually in different alternate positions, maybe A, B, C, D, or A and C, and similarly B and D, both are the conjugate to each other. So this facilitates the formation of a stable system within the polymer system. Now, what are the requirement of resonance in any molecule? This is again very broad question. Now, the things is that, I mean, sometimes it may referred as a prerequisite for resonating system in any kind of a molecule. So, the molecule must have a conjugate system. So, let us ask about that, what are the different type of conjugate systems. So, I will discuss about a couple of things before we discuss further. Now, here there are things related to the conjugate system. One is the pi-pi conjugate. Now, the example is 1, 2. Now, here the pi bonds at position number 1 and position number 3. Now, another is the pi cation conjugate, that is a second approach. Now, here the pi bond, this is the pi bond at position 1, and this charge at position 3. Another is, the third one is pi anion conjugate. Now, the example is, now here 1, 2, 3. So, the pi bond at position 1, and this is negative charge at position 3. Now, fourth one is pi lone pair of conjugate. So, one, two. Now, here the pi bond at position number 1 and lone pair, you see here lone pair at position number 3. Another is the fifth one is pi bond free radical conjugate. So, this is 1, 2, 3. So, you see that here this is the pi bond at position 1, and here this is the free radical at position number 3. So, this is the different type of the resonating concepts. Now, another thing is that the question arises that how we can draw the resonating structure. This is again a very typical type of thing. Now, again one basic question is that how to draw the resonance structure. Now, previously in the previous question we studied that what are the different type of conjugate system, and they are very useful in any kind of a polymeric system. Then based on this and in the sequence, then the question is that how we can draw any kind of resonating structure. So, let us have a brief about this approach. Like there are several things which we need to address. One approach is that we are having this type of resonating structure. Let put us like this. Then another resonating structure is like this. Then another resonating structure is like this. So, if we put the things in a sequential manner, then this may be like this. You see, this is the resonance structure. Now, in this example of 1,3-butadiene, the electron at pi bond at 1 and 3 position repel each other. So, this will result the shifting of electron either at position number 1 as shown in this thing like this, both are in the repulsive manner. So, this is in the this one, or at the position number 4 as represented here. So, these are 1, 2, 3, 4. Let me clarify this thing 1, 2, 3, 4. So, 1 and 3 here, 1 and 3 position, they repel each other. So, that this will result the shifting of electron, either they may acquire at this juncture minus and plus, or may acquire like this. So, therefore, the electron at position number 2 and 3 will try to fill the vacant space by joining a new bond at the position number 2. So, here there will be an opportunity to get the things done with respect to the. Now, there is a possibility of both positive and negative charge at position number 1 and 4, and hence no charge will be allocated at the final resonance structure. Now, as this pi bond is moving from position 1 to 4 here, there will be an equal possibility of pi bond at all place, which can be shown, or which we have already shown in this dotted lines. Similarly, we may have another approach, that is the example number 2. Let me have a blank sheet again. Example number 2. Here, this is. Now, here the concept of attraction. So, it may become, remember 1, 2 and 3, these are the positions. So, this may become like this, or sometimes resonating structure can be represented like this here. So, this is my resonating structure for this particular approach. Similarly, let us have another example of a repulsion. Now, here you may see this may acquire the negative charge, and the resonating structure would be like this. Another example of this one is, if you recall that here we are having the lone pair. This may have a tendency to move like this. In that case, like this. Similarly, another example, we may take another example like this. Another example, if you take these two double bonds, like we may have, now the charge is like this, here the positive, this one become the negative. So, it may become like this. The dotted line represents the resonating structure, or sometimes you may represent another form like this one. Now again we may have another example, that is example number 7, that is R. Now let us take another example of this type of approach. This is again my, now there is again shifting of these things. Now you see here, this acquires the negative charge and this acquires the things. There is a transfer of things over here, and the resonating structure becomes Let us take another example. This is RCOH. This is the structure. Now the resonating structure becomes so these are the various structures, as I discussed, that how we can draw the various kind of resonating structures in this particular approach. Now there is a concept of plus R effect, that is plus R and minus R effects in the resonance structure, that is positive and negative resonating effects. Now this plus R deals with the electron transfer from functional group to the system. Like here you see that OH, that what should be the sequential order for the transfer of these kind of functional group to within the system. Let's have another example of this particular approach, that is the plus R effect. Now you see that this is the lone pair. Now this is shifted to this one over here. Now you see now here this becomes a double bond and the lone pair is over shifted over here. Now yes, here and you see how this lone pair is shifted to the various positions as per the requirement. So this is there are, you see that there are 5 resonating structures in and around. So you may need to look all the possibilities of these resonating structures 1, 2, 3, 4 and 5. So these are the various effects attributed to plus R effect. Now let's have example of negative R effect. Now electron transfer from system to functional group. There is a difference, transfer from functional group to system. Now we are taking the transfers of from system to functional group. The sequential order in this category is already mentioned in the screen, that N2, CN, CHO, C double bond O, COR, etc. Let's have a look about the one example to explain the things for this one. That is the now see here, this is again our subject. Now this transfers to this oxygen, and the resonating structure becomes like this. this one. Now these are the 5 resonating structure, and overall you can write like this, just in a generalized manner if you are willing to write. So overall, just putting all these things. So there are overall 5 resonating structure, 1, 2, 3, 4 and 5, and if you wish to put, this is the overall one. So by this way we studied about the various kind of resonating structure, and based on this particular discussion, if we try to make a comparative statement with respect to the chain and step polymerization, you see that in chain polymerization the formation of high molecular weight polymer from unsaturated monomers is possible, whereas in the step growth polymerization the formation of a polymer from bifunctional or multifunctional monomer is possible. Similarly, in chain polymerization, the polymer growth is occurred by attachment of a single monomer at a time. Here in the step growth polymerization, the oligomer is formed first, which then combined together to form the polymer chain. So these two are the basic differences between the chain polymerization and step polymerization. Another thing is that in chain polymerization, there is no rapid loss of monomer at the beginning, whereas in step growth polymerization, there is a rapid loss of monomer you can observe at the beginning of the reaction. Similarly, in chain growth polymerization, the reactive species are needed to be terminated to end the reaction, usually the termination step, and this is occur when compound of desired molecular weight and properties is formed. In step growth polymerization, each monomer is a reactive species by itself. So it is a very crucial point for carrying out this step growth polymerization. In chain growth polymerization, the required initiator should be there. So it requires an initiator to start the reaction, whereas there is no such type of requirement in step growth polymerization. It can occur suo motu. In chain growth polymerization, no polymer growth after you have one termination step, but step growth polymerization on the contrary, it shows no termination step. And in chain growth polymerization, you can observe any kind of molecule, any type of a molecule, whereas in step growth polymerization, only monomers and polymers you can see in this particular approach. Now in chain growth polymerization, the polymer's molecular weight is largely unchanged, though the average percent conversion of a monomer to polymer increases with respect to the time. In step growth polymerization, the molecular weight increases throughout, no doubt. The course of the reaction, the polymer of high molecular weight is usually not obtained until the polymerization ends. So you can see that all depends on the chain type of structure. Another comparison between both of polymerization protocols are the chain growth polymerization, they are relatively low reaction time is required to get high molecular weight polymer, whereas in step growth polymerization, the longer reaction times are sometimes important for carrying out higher conversion percentage as well as a higher molecular weight. So by this way we carry out a brief comparison between the step growth and the chain growth polymerization. So at the outset in this particular lecture we discussed about radical polymerization, we discussed about the various kind of resonating structures, different type, how we can have a different type of resonating structure especially related to the polymerization process. Then we had a brief study about the comparative note on the distinguishment between the chain and step growth polymerization. So thank you very much for your attention.